Good morning. Am I audible? Yes. Yeah. Having the same network issue as yesterday. Yesterday during our last 10 minutes, okay, so we had the network issue that still not resolved. Yesterday, I guess Harsh was having a question, right, which we didn't take yesterday. Yeah, Harsh, are you there?
Yes, sir. Yeah,
Yeah.
yeah.
Yes. So we'll take that right now.
Hmm.
Yeah. Come again. What was the question?
Yes, sir. The question was, in the figure, there was a vertical pole, and one was the horizontal axis, which was like about 30 degree to one side and 20 degree to one side.
Yes. Just a minute. I'll take that question. Yes.
Yes, sir.
Hmm.
So, in that, the 30 degree angle is there one side, and the another side is 20 degree angle. Yes, sir.
Yes. Yes.
And so I was asking whether this 30 degree and 20 degree angle, for that the axis is being tilted, or the 1500 Newton arrow or and the 500 Newton arrow are being tilted to 30 degree or 20 degree with
No. No.
respect to the x-axis.
Okay. See, none of them being. I'm not doing all that. Okay, because all the where is the point of concurrence of all the forces?
It's on
Where is the
A.
point of concurrence of
A.
all the forces? It is at A.
A.
Okay.
Oh,
So what I am doing, I am assuming my origin to be at A, or I am
okay.
shifting the origin to the point A. So then, in that case, what happens? According to the point A, with respect to point A, this becomes my first quadrant. This becomes second quadrant. This becomes third quadrant. This becomes fourth quadrant, right?
Yes, sir.
So according to that, then what happens here in the third quadrant? Both are negative, right?
Yes,
X
sir.
and Y values both are negative. In the fourth quadrant, you have X as positive and Y as negative. So
Yes, sir.
by shifting my origin to A by okay, so shifting the
Hmm.
origin of the coordinate system at A, what I am doing, I am actually making it easier for me. Otherwise, just imagine that okay, if I'm keeping my coordinate system over here, okay, or over here, then for each of those points, okay, for each of these sign conventions, think about what you will have to do. So the easiest option is to shift the origin here at the point of concurrence.
Yes, sir.
Okay.
I just want to ask, the dotted line and that vertical pole, they both are at 90 degree to each other, no?
Yes, they both
Ah,
will. They
okay,
both are
okay.
90 degrees to each other. Yes, this
Okay.
angle it is 90 degrees.
Yeah, that was the.
Yeah.
Okay.
सर
Yes.
सर हमने 500 न्यूटन पर जो स्प्लिट किया है उधर एंगल 20 डिग्री है पर वो क्लॉकवाइज लिया है ना वैसे तो एंगल हम एंटी क्लॉकवाइज मेजर करते हैं
एक मिनट एक मिनट एक मिनट या अभी फिर से बोलो हमने
500 न्यूटन का जो फोर्स है वो जो स्प्लिट
हाँ
किया है उधर एंगल 20 डिग्री लिया है पर वो 20 डिग्री क्लॉकवाइज हमने मेजर किया कर लिया
हमने
है
विद
ना
रेस्पेक्ट टू एक्स एक्सिस लेना हमने हमने हर जगह में भी एंगल जो है हम वी हैव टेकन इट विद रेस्पेक्ट टू एक्स एक्सिस सो द 20
हाँ
डिग्रीज इज
वो
दैट विद
ठीक है
रेस्पेक्ट
सर
टू एक्स एक्सिस और वाई एक्सिस
नो सर बट वो एक्स एक्सिस के रिस्पेक्ट में वो क्लॉकवाइज लिया है ना वैसे
ठीक
तो
है ना तो
हम
कोई बात नहीं आप एक काम करो ना सो आपको टोटल एंगल कितना है 360 डिग्रीज सो हियर इंस्टेड ऑफ 20 व्हाट यू कैन टेक 360 माइनस 20 सो हाउ मच इट इज 340 आप एक बार कैलकुलेटर में चेक करो cos ऑफ 340 कितना है करके
एक मिनट
आप चेक करो cos ऑफ 340 कितना है तो यहाँ पे भी आपको कितना रहेगा cos ऑफ 210 देखना पड़ेगा cos ऑफ 210 देखना पड़ेगा आपको यहाँ पे ओके this angle which is there okay so as you are saying according to that okay so then this angle it will be 210 degrees this angle which is there this angle will be 360 minus what मेरा theta कितना था 53.13 right, so 360 minus 53.13, so 306.87 degrees, ये एंगल मेरा रहेगा 306.87 डिग्रीज एंड ये एंगल मेरा रहेगा 340 डिग्रीज। आप करके देख सकते हो, ओके, यू कैन चेक विद दैट ऑल्सो। ओके, आप एंगल वैसे ले सकते हो, इट्स नॉट एट ऑल इशू।
यस सर,
हाँ,
वो दोनों का आंसर सेम ही आ रहा है।
सो आप 340 ले लो या आप 20 ले लो, डज दैट मेक अ डिफरेंस?
यस सर।
सो आई होप आई हैव
थैंक्स।
आंसर्ड योर क्वेश्चन।
यस सर, थैंक यू सर।
Okay, so today we have 3 sessions right now. Okay, so right now we have 2 sessions continuously, and then just a minute. Okay, see I cannot be no, whoever okay who has not joined yet, okay, अभी आगे आप ऐसे जैसे एक ही बीच बीच में ज्वाइन करते रहोगे तो मैं करते नहीं रह सकता। ओके, तो आपके ग्रुप में एक बार बोल दो। Anybody joining out after this time right now will not be allowed inside. Okay, आपको बाद में या भी right now we have 2 lectures in continuous. Okay, so उसके बाद में आपको एंट्री होगा, तब तक आपको एंट्री नहीं होगा। ओके, so now today we'll be discussing, yesterday we started our discussion about coplanar concurrent force system, okay, and we solved a couple of numericals about it. So today we'll be continuing that discussion, and we'll also be looking at how to find out the resultant for a coplanar parallel force system. So the difference, and when I'm talking about coplanar concurrent force system, then I have all the forces which are the point of act, all the forces which are they are acting along the same point or on the same point. And when I'm talking about parallel force system, that means I have in the parallel force system I have like forces and unlike forces. When I am talking about like forces, then all the forces which are there, they are parallel to each other and they are acting in the same direction. Whereas when I'm talking about unlike parallel forces, then the forces they are acting, they are parallel to each other, whereas they are acting in in opposite directions. Okay, so that is the difference between like and unlike parallel force system. So we'll be looking at examples, okay, for both. And that is the outcome for today. Okay, so today I should be able to illustrate the concept of force, and I should be able to apply the same to compute the resultant for a coplanar concurrent force system and for a coplanar parallel force system. Okay, so now continuing our discussion from yesterday. Okay, so yesterday we had taken two numericals yesterday in about coplanar concurrent force system. Today's numerical, okay, so what is different in today's case, today's numerical is that, okay, So here I am in the starting itself in this question, a force of R equal to 25 kilonewton is acting at O and has three components. That means this force which is there, that is I am given the resultant here. This is my resultant. And this has three components. I have FA, FB, and FC, which are as shown in the figure. So the FA, which is there, that is a horizontal force, which is there, that is acting along the x-axis. The force FB, which is there, that is acting at an angle. Okay. So now the total angle for FB, which is there, that will be 60 plus 40. So the total angle for FB, which is there, that is 100 degrees. My total angle for FB, which is that is 100 degrees. And then the force FC, which is there, that is acting at an angle of 160 degrees from the positive x-axis. And I am given the magnitude of one of the forces, and I am given the resultant, the magnitude and the direction of the resultant. Now, in the previous questions, which in the first question that we had solved, okay, so we know the magnitudes of all the forces and the directions. We had to find magnitude and direction of the resultant. Whereas the second problem which we solved, did we look at? We were given the forces, and we were also told that the resultant, it is acting along the vertical direction. So for the first question it was that. Then for the second question that we solved, so we were given that the resultant, it is vertical. So R equal to sigma Fy, or implies that we had a sigma Fx equal to 0, and using that we were able to find out the magnitude of one of the forces. Okay, the tension in this guy cable. Now, in this question, so how do I start here? So firstly, I'll be requiring the angles, right? So I have the R, which is that is at an angle, acting at an angle of 60 degrees. Then FB, which is that is acting at an angle of 40 degrees from R. You see the angle it is given, it is in between. So with respect to my positive x-axis, what is my angle, total angle? 60 plus 40, 100 degrees. Or from with respect to y, which is there, or if I'm talking about, as we are taking the convention, so from here if I'm taking, okay, so that angle which is there, how much it will be? 180 minus 100, so that will be, this angle, it will be 80 degrees. Then the third case, the next force which is there, that is acting at 160 degrees from here. See, 160 degrees from here. So what will be the total angle for FC? Can you tell me what is the total angle for FC? 160 plus 60, right? So the total angle will be 220 degrees.
220.
So what is the angle with respect to x-axis? So with respect to x-axis, that will be 220 minus 180. So that is given 40 degrees. So this particular angle which will be there, that will be 40 degrees. Okay. So now we have seen all the forces. Then I have resultant R, which is that will be R into cos 60. Then I have R sin 60. Here both will be positive, plus. Then for in the case of FB, which is here, now in case of FB, what happens? I have FB into sin 80, and I have FB into cos 80. The cos component, since that is in the second quadrant, so the value will be negative, and this value will be positive. Then the force FC, for the force FC now, since it is acting along the third quadrant, so I have FC into cos 40, FC into sin 40. In FA, it does not have a vertical, it does not have a sine component, it has a cos component, and it will also by having FC, that is FA into cos 0, so that is equal to FA itself. So you can take the magnitude directly. Next, which is what I have to do, next I have to apply my equations, right? Sigma Fx equal to Can you tell me sigma fx? What will be the sum of sigma fx? Fa, which is that is again positive. So sigma fx it will be fa plus r into cos 60. R cos 60 plus
minus FB cos 80.
hmm. Hmm? Wait, fa minus fb cos 80, right? Cos 80 and then minus fc into cos 40. And this value which is there, that is equal to r into cos 60, right? I made a mistake earlier. So that value which is there, that total, this the total which is there, sigma fx, that is nothing but the x component of the resultant. So r into cos 60 now implies, what are the values that I know? I know the value only for fc, right? I do not know the value for fa and fb. So I'll be getting an equation fa minus, what is the value of cos 80? 0.1736 fb equal to value of r, it is 25 kilonewton. 25 into 0.5 plus fc value, it is 20. 20 into cos 40, 0.7660. So that which is there, that comes out to be as 25 into 0.5 plus 20 into 0.766 is coming it as 27.82. So this will be my first equation, fa minus 0.1736 fb equal to 27.82. This will be my first equation. Secondly, sigma fy equal to, in case of sigma fy, I have fb into sine 80, that is in the positive y direction, minus fc into sine 40. Now because fa which is that is acting along the x-axis, so it does not have a y component, equal to r into sine 60, or implies I have fb into sine 80 0.9848 minus equal to 25 into sine 60 0.8660 plus 20 into sine 40. Now I have to add the value of sine 40. 0.642, which is equal to 34.49. So implies fb into 0.9848 equal to 34.49, or imply what I can say, what I can find out, fb equal to 34.49 divided by 0.9848. So the value of fb, which is I am getting it as approximately 35.02 kilonewton, because in the starting which is all the values they are in kilonewtons, right? The unit it is in kilonewtons. So if the value of fb which is here, that is also again in kilonewtons. And then now I have found out fb, substituting fb in equation number 1 implies I have fa equal to 27.82 plus 0.1736 into fb. 33.8998 kilonewton. And since both the values are positive, okay, so what I can assume, what I can say, the directions that I have assumed, okay, so the directions are correct. So implies FA equal to 33.8998 kilonewton in FB equal to 35.02 kilonewton. Okay. So the previous question which were there, okay. So first question, what we had the value of, knew the value of all the components, and we had to find out the magnitude and direction of resultant. The second question, we knew the direction, we knew the direction of the resultant, and we were supposed to find out the one of the forces. Now in this here, we know the magnitude and the direction of resultant and one of the components, and we are supposed to find out the remaining components. So now since here we have we are talking about xy system coordinate system, so what happened, we had two unknowns and we have two equations, so it was easy, it was easier to solve. Okay, any question here? Am I hello, am I audible?
Yes, sir.
Yes, sir.
नहीं, पता नहीं
Sir?
चलता नेट in when I am in presentation mode. I don't know if I am in the network or not.
Yes, sir.
Okay, ये बीच बीच में पूछते रहूंगा am I audible सब. Okay, so don't mind that. Yes, you were asking something.
सर जो एफ ए वाला किया ना इक्वेशन फर्स्ट वो फिर से एक बार समझाओ ना.
आपको क्या नहीं समझा उसमें?
सेकंड स्टेप.
सेकेंड स्टेप में क्या किया है हमने? आपको क्या लगता है कि आपका अंडरस्टैंडिंग क्या हुआ? आपको क्वेश्चन किधर है? See, this is what I have written. It is basic mathematics. आप आपने LHS में एक इक्वेशन है, उसको मैं RHS में लिया एंड उसका वैल्यू किया, दैट्स ऑल. उसमें नहीं समझने जैसा क्या है?
यस सर समझ.
बेसिक मैथमेटिक्स है ना ये. इक्वेशन में कॉमन ले लो, सब्स्टिट्यूट करो. Okay, now we'll take one more question about concurrent force system, and then we'll move towards parallel force system. Okay, now here the striker of the carom board, which is that it is lying on the board and it is being pulled by 4 players as shown in figure. The players are sitting exactly at the center of the 4 sides. That means exactly ये जो A B C D जो भी मार्क किया है हमने, they are exactly at the center of that length. And ये पूरा बोर्ड का लेंथ मुझे कितना दिया है? It is given to me as 800 millimeters. Okay, so 800 millimeters, that means 0.8 meters. 0.25 meters, 0.3 meters. Now I am supposed to find out the resultant of the forces in magnitude and direction. Okay. So what makes actually this question different is यहाँ पे मुझे angles पहले से बताया नहीं है. I am given the length. Okay, I'm given what are the different forces. String tension कितना है मुझे दिया है अलग अलग. I'm given the string tension, and what do I know? I know the location. Okay, I marked the location. Now the angles which are there, I have to find out. So for finding out the angles, okay, so firstly I am given, okay, A, which is that is at a distance of 0.4 from here, right? So the distance B, which is here, ये distance भी जो है आपको कितना है 0.4 है, right? This was 0.3, this is 0.25, मैं वापस मार्क करता हूँ 0.8, this distance that is also 0.8. Now I have to mark the angles. Now for theta 1 which is here, so what I have to do, I'll be extending that line here. ये जो angle का line है, this horizontal line I'll be extending until here. So what is this distance? How much is this distance? Can you tell me?
150
800
mm.
800 mm. 0.15. Yeah. And what about the horizontal distance for the angle theta 1? What will be the horizontal distance? This total length it is
0.4.
800. 0.4 meter. This total length it is 800, and from that O it is at a distance of 0.3, right? So 0.8 minus 0.3, so this distance it will be 0.5. So theta 1, which is that is equal to tan inverse of 0.15 divided by 0.5. Okay. Now I have to go for theta 2. For theta 2, which is the triangle that I have to consider? For theta 2, I have to consider this triangle, right? Right, उस triangle में मुझे theta 2 angle है ना. So in that, what is ये horizontal distance कितना है मुझे? Can you tell me what is this horizontal distance? 0.1. Yes, 0.1. And what about the vertical distance? This distance, how much is it? 0.4. यहाँ तक का 0.4 है ना. ये line जो है from until here it is 0.4 plus 0.15, right? 0.4 plus 0.15, right? So that total distance it is that is 0.55. So for theta 2, which is there, I will be having tan inverse of 0.55 divided by 0.1. Now theta 3, which is there, that will be tan inverse of, for theta 3 angle kahan pe hai? Here. So I do not have to mark the triangle, it is already available. So I have 0.15, and ये horizontal distance कितना है मेरा?
0.3.
0.3.
0.3. रिपीट करने की जरूरत नहीं, किसी एक ने बोला काफी है. ओके, रेस्पॉन्स इज इंपॉर्टेंट. स्कूल के जैसे सब लोग बोलने की जरूरत नहीं है. ठीक है, कोई एक बोलो काफी है, repetition नहीं चाहिए. Okay, then what about theta 4? What is the triangle for theta 4? The small triangle, right? So here what is the length?
0.25.
The length is this is 0.1, this is 0.25, right? So for this I have theta 4, which is that is 0.25 divided by 0.1. So by doing the calculation, which is that I can get the angles. Okay, so theta 1, which is there. Okay, let me do one thing. Let me write it here. Theta 1 equal to 16.699 degrees. थीटा 2 बोलो वैल्यू कितना है आपके पास? सभी कैलकुलेटर है. थीटा 2, थीटा 3, थीटा 4. एक एक 3 लोग अलग अलग लोग कैलकुलेटर में डालो और फट से बताओ. theta 2, value of theta 2.
Sir, I have found out value of theta 4.
Okay, give me value of theta 4.
68.1985.
68.1985 degrees. Okay, fine.
Say theta 2,
Yeah,
79.6951.
degrees. Okay, fine. Now we are left with theta 3.
Theta 3 26.5650.
26.5650 degrees. Okay, fine. Now we know the angles. Okay, next what I have to see, with respect to my origin at O, I have to mark the directions. I have to mark the result components, right? So for 20 Newton, which is there, I have 20 into cos theta 1, 20 into sin theta 1. Next, here I have 25 cos theta 2, 25 sin theta 2. And here 10 cos theta, 10 sin theta 3, sorry. 10 sin theta 3, 10 cos theta 3, and finally 15 cos theta 4, 15 sin theta 4. The sign conventions which are there, plus, plus, okay. So now we'll start from the positive x-axis. We'll start from the first quadrant, and we'll sequentially we'll be writing the components. Okay. So we had found out the values of theta 1, theta 2, theta 3, and theta 4 already. So here what I'll be doing, I'll be writing the expression which is a sigma fx equal to 20 cos theta 1 plus 25 cos theta 2 minus 10 cos theta 3 and plus 15 cos theta 4. So I can substitute the angles and I can get the value. Same way, sigma fy equal to, firstly I have 20 sin theta 1, secondly plus 25 sin theta 2, thirdly plus 10 sin theta 3 and minus 15 sin theta 4. Now I have to quickly substitute the values and I have to write the answer. Okay. So 20 cos theta 1 which was there. So in this question, what the first step that I have to do is to find out these angles, right? So first I'm finding out these angles, I'm writing the values of theta 1, theta 2, theta 3 and theta 4. Then after that only I'll be going with for sigma fx and sigma fy. So can you calculate it and tell me the value for sigma fx?
20.2553.
Just a minute, let me write it down. 20.2553 Newton. Okay. Let me check that. Yeah. So the 20.2553 Newton, that is correct. Yes, what about sigma fy?
20.888.
20.8886 Newton. Okay, so I've got the values for sigma fx as well as for sigma fy. So now I can find out the magnitude of the resultant, r equal to under the root of sigma fx square plus sigma fy square under the root 20.2553 square plus 20.8886 square. Magnitude is I'm getting it as 29.0966 Newton in the direction which is there. Okay, so alpha equal to tan inverse sigma fy upon sigma fx, tan inverse of 20.8886 divided by 20.2553 Here one thing I did not do is, so sigma fx, the value it is positive, so the direction which is there, that is towards the positive x-axis. Sigma fy, it is also positive with the direction the positive y-axis. So my resultant, which is, that is going to lie in the first quadrant. Okay, sigma fx is positive, sigma fy is positive, so my resultant, that is going to lie in the first quadrant. And this angle, which is whatever angle that I'm getting, that will also be positive. Okay, so I have to measure it from the positive x-axis. Okay, so what is the value of angle?
.8818.
So alpha equal to 45.8818 degrees. Price R equal to 29.0966 Newton, and alpha equal to 45.8818 degrees. I'll do one thing, I'll mark the resultant now, right? So now that we have found it out, okay, so let us mark the resultant. Now the resultant is that is we have to calculate all the forces which are from the point O. So my resultant, which is that also I'll be marking from the point O, and since the value which is that is 45.88 degrees, that means okay, so approximately 46 degrees. R equal to 29.0966 Newton. लेट मी मार्क इट हियर. ओके, सो वो डायग्राम में हमने बहुत ज़्यादा ये किया है, सो हम यहाँ पे मार्क करते हैं. नहीं, okay, any question?
No, sir.
But in exam, we have to write perfect point answers, or a point answer may differ somewhat.
It is up to you. I generally prefer to write up to third or fourth place of decimal. वो मेरा चॉइस है. आप सेकंड प्लेस तक भी लिख सकते हो, कोई इशू नहीं है. ठीक है, लेकिन बस इतना मेरा रिक्वेस्ट है कि हर एक स्टेप में राउंड ऑफ मत करो. यहाँ पे हर एक स्टेप में ना राउंड ऑफ करते मत जाओ. एट द लास्ट अब थोड़ा ठीक है, 29.096 इसको आप ठीक है 29.1 के न्यूटन बोला, 45.886 है, ठीक है, अप्रोक्सीमेटली 46 डिग्रीज बोला, ठीक है. यहाँ पे 20.25 इसको मैंने 20 न्यूटन बोला, इसको मैंने 21 न्यूटन बोला. ऐसे मत करो, सबसे लास्ट स्टेप में राउंड ऑफ करो. ओके, दैट एक्चुअली रिड्यूसेस माय कैलकुलेशन एरर.
Okay, sir.
कैलकुलेशन एरर उसका एक्चुअली हम लोग इसके टर्म्स में बोलते हैं, हम लोग उसको राउंड ऑफ एरर बोलते हैं. पूरे कम होता है. ओके, वी कॉल दैट एज राउंड ऑफ एरर. वो कम होता है अभी. ठीक है.
Okay, sir.
So apart from that, any other question?
No,
Not?
sir.
Okay. So I hope all of you are you will now be able to solve a question. Okay, if I'm giving you a questions, and you'll be able to solve about parallel force system, है ना, for about concurrent force system, है ना.
Yes, sir.
हाँ, तो एक काम करते हैं, एक छोटा एक्सरसाइज करते हैं. सबके पास कैलकुलेटर है?
Yes,
Yes,
sir.
sir.
ओके, फाइन. सो आई विल गिव यू अ क्वेश्चन, आप सॉल्व करो और आप बताओ. Give me a minute, I'll give you one question. Simple question to solve. लेक्चर चालू है, लेक्चर चल रहा है मैम. Okay, screen is visible.
Yes,
Yes.
sir.
Okay. Yeah, this is your question. Okay, so quickly, it will take only 5 minutes. Find, you are supposed to find out the resultant. Okay. In this here it is there. Okay, so it is given, it is as 3 divided by 4. Let me write that here. 3 and this is 4. Okay, so this, which is this angle, which is, that is 3 divided by 4, 3 by 4. Okay. This is a previous university question that you are solving right now. Okay.
Opposite क्या है? Opposite.
So resultant is 126.041.
Yeah, have you completed?
Yes, sir.
Yeah, a value.
Sir, for me, resultant is 126.041 and
Hmm.
alpha is equal to 72.8163.
Hmm. Resultant, how much? What is sigma sigma fx
27.85,
and sigma fy?
90.06,
So then, how will be r will be how much? 120.
6.041.
How is it possible?
Sir,
What is the
might
equation
coming
for
to be
r? What is the equation for resultant?
sir.
Uh,
Sigma fx, which is what is the value of sigma fx? 20.
7.85
Okay, 27.85 newtons. Sigma fy
to 90.06.
90.06 newton. Okay. What is the equation for resultant r?
Under root of sigma,
Under the root of completed.
yeah, sigma fx square plus sigma fy whole square.
Hmm. So under the root of 90 square plus 27 square, right? Do that.
Sir, it might coming to be 94.2726.
Exactly. Even if I'm forgetting about them, I'm doing it as 90 and 28. Okay, so my resultant I'm coming it as 94.25 newton. You did not do this
My
under the root of sigma
calculation.
fx plus sigma fy square. You simply added them.
Oh, sorry, sir.
Don't make this mistake in exam. Okay.
Yes.
Sir, and theta is alpha is coming to be
So
72.81.
for me, okay, the magnitude of resultant which there I got it as 94.2767 newton in alpha, which is I got it as 72.82 degrees.
Yes, sir. Alpha is correct.
Okay. So these are the values. So if you have not got them, okay, so check your calculations again. Just a simple two-line problem it is there. So yeah, mistakes are not expected from such this question. There is also not much of positive and negative, just the 25 newton that is having a negative, like that it will be the x component of 25 newton that will be negative. All the other values are positive. Okay, so nothing much of an error is to be expected. So now with that we conclude our topic about concurrent force system. Okay, and we'll proceed towards coplanar parallel force system. Okay, so when I am talking about here, okay, so when we discussed about coplanar concurrent force system, So in that case, what happened? We had all the forces which are there. The point of action of all the forces which are there, it is along the same point, right? So then I just have to take the algebraic sum of the x components and the magnitudes of along the x and y components, and then these are simple algebraic expressions. But when I'm considering a parallel force system, okay, so when I'm considering a parallel force system, so then what happens? I have now this is an unlike parallel force system that I've made. So in this case, now when I'm taking just the here, okay, what happens? I do not have sigma fx at all, right? So when I'm considering this system of forces, parallel force system, either I'll be having for this particular system, I'll be having only sigma fy, sigma fx, which is that is already equal to 0. I do have only sigma fy. If I'm considering a system of forces like this, then here what happens? I have only sigma fx, sigma fi value which that is e0. So then how do I evaluate? Okay, how do I find out the resultant? How do I find out the for this case? Okay, so since all the forces were concurrent, so what happened? I had to find out. I found out the angle also. So here, when I'm considering a system of parallel forces, so it is obvious that my resultant, which is there, my resultant will also be parallel to this system. But then the resultant, okay, so from what the point of action which is there, the point of action of the resultant, or the point of action or the line of action which is there, that I have to find out. So then to find that out, what I am doing, okay, so previously I had just about sigma fx0 and sigma fy0. Now what I am doing, I am adding the summation of the moment. Okay, so the summation of the moment, which is a sigma m equal to 0. I'm adding one more equation. So here, so when I'm talking about parallel force system which is there, so here I'll be considering sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. So if my forces, if at all sigma fx becomes equal to 0, then what happens? I have sigma fy and I have sigma m. I have two equations. I still have two equations to solve. If in the case of my horizontal force system, then I have sigma fy equal to 0. So I'll be left with sigma fx and sigma m. Okay. So for a parallel force system, to always have at least two equations to find out the unknown. For that, what we are doing, we are taking it like this. Okay. And when I'm talking about a parallel force system, I'll also be discussing about Varignon's theorem. Okay, so we'll be discussing that right now. So before that, okay, so what is the moment of a force about the point? So right now I have this object here. I have this circular cylinder here. Okay. In this cylinder, it is having a distance. Okay, that it is having say a radius of r here, and I have a force which is there, a force F which is acting at the periphery around the circumference at this particular point. Now, due to this action, due to this force, okay, so along this point, oh, along the center of my this, what happens? It creates a turning action. It creates a rotational effect. So right now, because of this force which is acting here, so what happened? If at all, if I am considering my wheel, अब मैं wheel को जब rotate करता हूँ तो क्या करता हूँ? It is the wheel, it is rotating along the center, right? The wheel, it revolves along the center. So that same thing. So that force which is there, that force which causes it to move, the force which causes the rotating turning effect or the rotating effect which is there, such a force, that effect which is there, that is said to cause a moment, okay, because of that force along that point. So that is what we'll be discussing now. The rotational effect produced by a force is known as the moment of the force. So now that is okay, fine. So how do I find out the magnitude of the moment then? The magnitude of the moment. So now to find out the magnitude of that moment, okay, so what we always say is the product of the magnitude of the force and the perpendicular distance. Product of the force and perpendicular distance. the distance, it always has to be perpendicular. Okay, so that is one thing that I have to remember. The moment of the force about the point O, which is here right now, about O, which is defined as F into D, where D, which is there, it is my perpendicular distance. Okay, the moment vector which is there, it always has to, it is perpendicular to the plane. Okay, so MO equal to the magnitude which is there, the magnitude of the moment which is there, that measures the tendency of the force to cause the rotation, and the direction of the moment which is there, that is determined by the right hand rule. So by the right hand rule, what I'll tell you right now, that what is the right hand rule. Okay, so right now here I have the force F. I have two diagrams here. Okay, so in the first diagram I have the point O, which is here, and I have a force which is acting along here. So the least distance which is there, the perpendicular distance of F which is there from the point O, that is given by D, and the effect of this moment, of that moment which is there. Okay, so I have O here, and the force F which is there, that is causing a rotational effect about the point O, and that rotational effect, it is in the anti-clockwise direction. And by the right hand rule, the anti-clockwise moment which is there, that is always positive, and the clockwise moment which is there, that is always negative. That is one point I have to remember. Okay, any force F which is there, that has the same magnitude and direction as F, produces the same moment. Secondly, so some of the properties are here. Okay, two-dimensional structures have the length and breadth, but negligible, are subjected to forces contained in the plane of the structure. As per right hand thumb rule, the magnitude of the anti-clockwise moment is positive, and the clockwise moment with the magnitude of the negative moment which is there, it is the magnitude of clockwise moment, it is negative. I always have to remember that. Okay, if at all, okay, well, during I am solving my question, so if I have a doubt, then what I can do, use your right hand. Okay, so right now in when you are you when we right now, I want you to look at okay, I want you to look at my camera. Okay, so here in the right, when I'm talking about right hand thumb rule, okay, what you can do, you can keep your thumb which is there at whatever the point of rotation you have to, and then you rotate your fingers accordingly. Okay, so suppose if my force which is there, from here, if my force, it is acting in the this direction, so it will be producing an anti-clockwise movement, and that anti-clockwise movement which is there, that is called as, or that is given a sign combination of positive. Am I audible?
Yes, sir.
Yes, sir.
Anti-clockwise moment is always positive, clockwise moment is always negative. And how, okay, in a layman's word, so how can I find if it is the moment it is producing a clockwise moment or an anti-clockwise moment? Keep your thumb along the point, at the point of the rotation, and then accordingly rotate it. Rotate your little finger which is there along that force direction. So you can see that you will be able to see, look, find out if you're having a clockwise moment or an anti-clockwise moment. Okay, right now आप मेरा कैमरा में देखोगे क्या होगा मेरा, it will be exactly opposite, right? So right now this will be, you will be able to see it as my left hand which is moving. Okay, then, so when I am talking about the force, one force which is there, okay, so along with the same, this was the effect of a single force. Now there is, in the next which is there, it is the effect of a couple. What is a couple? A couple is a special case of a parallel force which is there. Two forces of which are of equal magnitude and in opposite direction, they will form a couple. And the effect of the couple which is there, it is to rotate the body along with it, along on which it is acting. So I have two forces which are there. Here the forces here, unlike parallel forces of equal magnitude. So right now here I have here the forces that are there. Okay, so I have F in this, in along this direction, and this along this. So this, both these forces together which is there. Okay, so F, it is causing at this point, if I'm considering F, it is causing a rotation in this direction. And if I'm considering this point, okay, so then F with this force F, which is that is causing a rotation in this direction. So that's why this moment, this coupled, which is that is causing a totally, it will be causing me a clockwise moment. So the sign convention, it will be negative. This moment here, it is causing me an anti-clockwise movement, and hence that is a positive moment. That will be having a positive convention. And what is the unit of moment which is there? The unit of moment, it is Newton meters. Okay, the SI unit of moment which is there, that is given by Newton meters. Okay, there are some properties of the couple which is there. Firstly, the couple tend to cause rotation of the body about an axis perpendicular to the plane containing parallel forces. Secondly, the magnitude of rotation of the moment of a couple, it is equal to product of one of the forces and the arm of the couple. Then, what is the arm of the couple then? The distance between the two forces which is there, that is known as the arm of the couple. Couple, it is a free vector. Okay, so it can be moved anywhere along the on the body on which it is acting without causing any change. So in this case here, which is there. Okay, so if at all I am showing, okay, I am showing an in this case, okay, suppose I am showing that, okay, I have a couple, I have a moment here, okay, say like some 10 Newton meters which is there, it is acting here. So what happens, this for 10 Newton meters which is there, it can act here also, it can, I can say that I can show it as acting here also, or I can show it as acting at here also, or I can show it acting here also. Couple is a free vector. उसको आपको क्या है? It is acting on that entire system of forces. It is the couple is that does not have a point of action. It causes an overall rotational effect. ठीक है? So the point of action of a couple is unnecessary, and इसीलिए I call it as a free vector. Okay? Understood? Then the resultant force of a coupled system, which is that is equal to 0. Then to balance a system whose resultant is a couple, then another couple of the same magnitude and the opposite sense is required. So now I have a system in which I am having a clockwise moment. Okay, जिसका net effect जो है, net resultant मुझे moment है having a clockwise moment. Then for the body to be in equilibrium, I should be adding a moment of equal magnitude. Okay, m equal to f into d, but in opposite direction. Only then that system it will be in it will be in balance. Then if I want to move a force to a new parallel position, okay, one force it is there. Okay, so that will be discussed. I'll showing you right now. Okay, that
Sir?
how, yes.
Sir, that fifth point you mean in order to keep it stable in
Yes.
non, when we have to add another in opposite
Yes,
direction.
if it is necessary, okay, if at all in an entire system, okay, if an entire system there is a couple which is my resultant comes to be as a couple, then to keep that system in equilibrium, I'll be requiring to be adding a counter couple which is there. Okay, I'll call that as a counter couple, which is of the same magnitude as the couple but in opposite direction. मेरा सिस्टम का ओवरऑल कपल मेरे को क्लॉकवाइज में मूव कर रहा है, तो मैं एक एंटी क्लॉकवाइज का एक कपल ऐड करूंगा, so that
Yes.
they will be cancelling each other out and the system remains to be in equilibrium. Okay, then to shift a force to a new position, a couple is required to be added to the system. So that is what we'll be seeing in the next next few minutes, that how I can, okay, here if at all, okay, so right now I have a force here, I have A and B are 2 points in this plane, and I have a force F which is acting along from through the point A. Now I just, if I am required to, if I want to change that force F which is that, if I want to change that force F and I want it to act through the point B, then what I can do, because in the entire system which is there, okay, my force, the remaining rest of the force that should be acting, that is F. So through the point B, I'll be passing, कि मैं assume कर रहा हूँ कि through the point B I have an equal and opposite force of magnitude F. तो यहाँ पे क्या हो जाएगा, this F and this F they will be cancelling each other out, and I left with net effect of F only. So through the point B, which is there which is at a distance of D, I am adding an opposite system of forces. So A and A, both of them will cancel each other out if required. And here, okay, then what I do, I keep this magnitude and I'll be considering this force 1 and 2. Now 1 and 2 which are there, that is a system of unlike parallel forces having equal magnitude. So that unlike parallel forces of equal magnitude at a distance of D, that transfers into a couple. So what is the magnitude of that couple? F into D. So now for the force which was acting through the point A, now I have transferred it to the point B, and because of the turning effect, the net effect of that, which is there, a couple is added into the system having a magnitude of F into D. Okay, any question here? That was
Sir,
this was about the sixth point which was there.
yeah, sir, one question was there.
Yeah,
In the second figure, we have
yeah,
added F in the opposite direction, both in the opposite direction.
yeah.
And if we see by the figure, all of the F constitute the same magnitude.
Yes, all are
Therefore,
in the same magnitude.
therefore, through the B point,
Hmm.
those F which are in opposite direction, they should cancel each other, na? Instead of that, they have
Yes.
produced that couple
Yes,
force.
when I'm finding out the resultant which is there, when I'm finding out the resultant, okay, see, if in some cases, in some examples, I may be required to be actually transferring a force from one location to another location. But see, if it was a moment, then if it was a couple, then what happened? The couple is a free vector. It can act anywhere along that entire plane, right? But a force which is a force, it has a point or a line of action. So if I want to change that point or line of action for my requirement, then this is how I'll have to do that. I'll have to add an equal and opposite force, okay, along that wherever the point of action, the new point of action, then these two which will they'll be comprising of an equal and opposite force, okay, equal and opposite force along the acting along a distance. So these two forces which are there, they'll be becoming a new moment. Now if at all, okay, if this magnitude which was there, अभी मुझे यहाँ पे नहीं, if I want to add say here, okay, if I want to add here, then what to do? Then this will be having say another distance here, this point C which is then, that is at another distance here, say this distance which is there, that is say R. So if I want to if I want to transfer this force F which is there to the point C, then at the point C I'll be adding an equal and opposite force F and F. So now I have force which is acting through the point F, and I have two like parallel forces here, right? Unlike parallel forces of equal magnitude. So this F and this F together, they'll be forming a moment, and the direction of the moment which is there, that will be clockwise, because the force because of this moment which is there, it is causing me this is causing a moment in which direction here, and the force F, this force, it along the point C, it is causing a moment in this direction, right? It is causing a rotational effect in the clockwise direction. So the overall effect which is there, that is a moment in clockwise direction.
Yes, sir. And in addition to that, a moment which we have created, that
Hmm.
force is also there, na? The another force which
The
we have
moment, yeah,
created.
in addition to the force, I have a moment also added.
Okay, sir.
Yeah.
So if we have to find resultant in the third figure, then we have to, I mean, if it is asked to find the total effect, then we have to add the
For
single force plus moment also.
see, see, there comes the difference. Okay, I have now where I told you that when we are talking about parallel force system, then we have sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. So when I'm talking about here in this case, okay, so either sigma fx, this will be, if this is 0, then sigma fy, that becomes, the net effect becomes as f only. It does not change. The total,
Yes, sir.
what is the total force acting in the system? It is still f only. And sigma m which is there, that becomes that adds. Previously also that was there. When the force was acting through A, what is the total moment acting about point B? That was f into D. So that was already there. Okay. But now what change is happening now? I have that force F which is there, that was previously acting through the point A. The point of action which is there, the line of action was through A. Now that force F, it is having a line of action through B. Okay, that is the only That is a physical difference which is happening. In my overall calculation, no difference will be there.
Okay, sir.
Okay, when I'm considering the entire system, nothing is changing. When I'm considering the individual point of action or the line of action, then that change is coming, and that is what is important. Okay, now the same ways, this was about to change the force into a force coupled system. Now, if I want to change a force coupled system into a force, what I have to do from the point A, which is there, okay, so I have this force of magnitude F, and I had a moment. So from A, since the moment it was in which direction, the moment it is in anti-clockwise direction. So from A, which is there, I'll be taking a distance. Okay, so this distance d, which is there, that is m divided by f. So the distance d, which is there, that is m, the moment divided by the magnitude of the force, and I'll be shifting that force to that much of a distance. That's all. When do I have to use this? अभी हमने ये सीखा, लेकिन हम ये use कब करेंगे? When I am talking about a general force system, if at all required. Okay, if required, if necessary, in the case of a general force system, or in the case of non-coplanar force system, which is that non-coplanar force system, वो सब के वहां पे सब में हमको जरूरत पड़ सकता है. Okay, so we'll see. Okay, we'll try to take a couple of an example for this case also. Okay, now the moment of a couple. Okay, we saw the properties of couple which are there. Now the effect of moment of a couple which is there. So, okay, so this is a small slight derivation which is there. I have two forces F of equal and F and minus F. Okay, according to the direction, having same magnitude, the parallel line of action, and the opposite sense. Okay, that means it is an unlike parallel forces which are there of equal magnitude. It is forming a couple. So the moment of the couple which is there, a small, very small derivation part just for your knowledge. Okay, just for your information. Okay. The moment vector which is there, m equal to r into f sine theta equal to f into d. Now, two couples, it will be, they will be having equal moments. Okay, that is quite possible. Two couples will say they will be having equal moments if, firstly, f1 d1 equal to f2 d2. I have two couples here. So the product which is the product of the force and the distance, f1 d1 equal to f2 d2. Secondly, the couples which are they are lying in parallel planes. And thirdly, the couples, they have the same sense or the tendency to cause in the same direction. Right now, this system, this couple which was there, this couple, it is causing me the f1 into d1 force is there. That is causing me in the moment in which direction? That is causing me a moment in anti-clockwise direction. What about f2 into d2? F2 into d2, that is again
Anti-clockwise.
causing me a moment in the anti-clockwise direction. So what I am, depending on the magnitude of f1 d1 and f2 d2, so then after that I can say that probably the two couples which are there, they are having equal moments. This part, which is the transfer of the force in the opposite direction, that we saw already. Now we have to look about Varignon's theorem. Okay, so what? Now, what does Varignon's theorem say? Okay, so right now I told you that when we are talking about parallel forces, then we have sigma fx equal to 0, then sigma fy equal to 0, then sigma m equal to 0. But what does Varignon's theorem say? The moment of the resultant of all forces in a plane about any point is equal to the algebraic sum of the moment of forces about the same point. So sigma m, which is there, that what Varignon's theorem says, the moment of the resultant of the forces. So the moment of resultant, that means we know that the resultant force, it is, we are showing it as r. The resultant force r equal the effect of the moment of resultant r. So r into probably the distance which is there, that is given as d. That is equal to sigma mo. Sigma mo, which is there. So instead of writing it as sigma m equal to 0, I am replacing it by sigma m, which is there, that is equal to r into d. where r will be the magnitude of the resultant, in d which is there, that is the perpendicular distance. Okay, that will be the perpendicular distance of the resultant. What
Sir,
the yes.
so that sigma fx equals to 0, sigma fy equals to 0, and sigma m equals to 0. We took all of them three equals to 0 for the parallel
No,
and
instead of
convex.
yes. So what Varignon's theorem tells me is that sigma fx is 0, sigma phi 0, there is no change in that. But instead of sigma m equal to 0, which is there, so that is to be replaced with sigma m equal to the product of the effect of resultant. So the
Yeah,
net moment which is there, the net moment of all the forces, that will be equal to the moment of the resultant of that same system of forces.
yeah. That I understood. I just
Yeah.
want to ask the initial one where all the three values are taken as 0.
No, no.
That all of the it stood as for unparallel. I mean, parallel concurrent forces, now which
No, no, not the sigma fx equal to 0, sigma fy equal to 0. Not is it is not necessary for only for concurrent force system. Okay,
okay.
when I'm talking about a parallel force system, okay, so there I have added actually sigma fx equal to 0. I'll be
Hmm.
taking sigma fx equal to 0. Then I'll be taking sigma fy equal to 0, and I'll be taking sigma m equal to r into d. Three
Okay.
equations. I have three equations to solve. Okay. Now, when I'm talking about a parallel force system, then probably depending on the my direction which is there, either I may have maybe sigma fx as 0 which is there already. आपको sigma
Hmm.
f x direction में अगर force ही नहीं है तो आपको ये
Hmm.
equation लेके मतलब ही नहीं है ना. Then you'll
Yes,
be
sir.
having left with only two equations.
Okay.
If my force is acting only along the x direction, then मुझे y
Hmm.
direction में force ही नहीं है. So then I'll be left with only these two equations.
Okay.
Okay.
So that I understood, sir. I just want to ask that
Hmm.
sigma m equals to 0, which we have written.
No, no, no.
Uh,
That is what Varignon's theorem tell me, that it is not
uh,
sigma m equal to 0, it is sigma m equal
okay.
to r into d.
Okay, sir. Okay.
Okay.
Yes, sir.
Yeah. No, it is a very small a very small thing. Okay. We'll take a couple of minutes of break. Okay. I'll take a couple of minutes. Let me have a little water. We'll take a couple of minutes break. Okay.
Sir, please show previous slide. Hello, sir.
Yes.
Please show previous line.
Hmm. Okay, so from Varignon's theorem, okay, so I'm supposed to be proving that product R into D equal to P into D1 plus Q into D2, or what according to Varignon's theorem, what it's saying, the sum of the moment of the resultant which is there, that is the sum of the individual moments. So the sum of the individual moment, firstly I have the force P which is there, P it is acting and Q it is acting. So I have the resultant which is there, and when I'm writing in terms of vector, okay, so I have R equal to vector P plus vector Q, right, in the vector form. Now when I'm resolving it into components which is there, resolving into components, I have Rx equal to Px plus Qx in Ry which is that is Py plus Qy. Now what is the x component which is there? Ry which is there. I have the force R. So Ry which is there, I know the angles already, right? Ry which is there, that is what is, can you tell me what is Ry? P which is there, that is moment of P which is there, that is P into cos theta 1 and P sin theta 1, right? Here R cos theta, R sin theta. Then here Q cos theta 2, Q sin theta 2. Abhi, I have some more actually points right now which is there. Okay, so I have along my positive x-axis which is there. So about the point O, मेरा x component का मेरा line of action कहाँ से है? What is the line of action for the my x component which is there?
So through O only.
It will be through O and along the x-axis, right?
Yeah.
What for R and for Q, all of them it will be the same. So what will be the effect of does it have a rotational effect? The cos component which is there, the horizontal component, does it have a rotational effect? That is another property of the moment. If any force which is there, if any force which is there, okay, I have the force here and it is passing through from here. Okay, if the force is passing through that point, then that force it will be there, it will not be having any rotational effect about that point. So the cos components which are there, here the cos components, for all the cos components which is there, my m which is there, m will be equal to 0. So P cos theta which is there, does that have a horizontal distance? Does that have a normal distance P cos theta? That does not have a normal distance, right? It is passing through here. So any P sin, whereas for P sin theta which is there, so when I'm considering, if I'm considering this triangle here, so P cos theta, that is along this direction. P sin theta component, it is from here, right? So here, what is my P sin theta 1? P sin theta 1, the line of action it is here, right? Let me go back here. I'm try to understand this. Okay, it is important. And P cos theta which is there. So this term it will be this component. This will be P cos theta 1. This is P sin theta 1. Correct? Same
Yes,
way.
sir.
Same way here. Here I have R sin theta, R cos theta, and here I have Q cos theta 2, Q sin theta 2. Now here, I want you to observe at cos theta, the cos components which are there. The cos components, they are passing through the O itself. They are passing through O itself. So implies the moment of p cos, the moment of p cos theta, that is will be equal to 0. The moment of r cos theta, that will be equal to 0. The moment of q cos theta, that will be equal to, also be equal to 0. Which components have the moment? Now the sine component which is there, that is my height. So it will be having a horizontal distance here, right? What it will be having some horizontal distance. So about O which is there, the sine component that has a rotational effect. The r sine theta, that also has a rotational effect. The q sine theta 2 component, that also has a rotational effect about point O, because it is the point, that force which is there, the sine theta component, that is at a distance from O. So whatever that distance it was, okay, so it is at some distance, and hence that actually gives me a moment. So that is why here I am considering only the y component. Okay, I am not considering the x component here. Okay, understood? So let me erase this off. Okay, I explained it in the previous slide.
Sir,
Yeah,
one question.
yeah.
Uh, all of these three forces, like for the resultant, for the Q, and for the P,
Hmm.
they all have perpendicular from the point A. Okay. Uh,
They
yeah,
have they
D1,
have
D.
yes, the perpendicular from the point A, that is actually the minimum distance, that is the least
Yeah.
distance, right? Yeah.
So, but we took the direction of force for the axis O to here. How, sir? Like we took
No,
the
I actually,
force.
what I here, okay, in this slide, what I tried to explain you is that the mostly in most of the cases which are there, okay, so the if any force which is there, if that force it is passing through the point of rotation, if the force is passing through the point of rotation, then
Okay.
you will not be having a moment of that force. That
You mean
was
through
what I,
A?
yes. So that is
Okay.
why
Okay.
for this case, I what happened, I the cost, all the cost components which are there, the cost components do not cause any moment about O. Only the
Yes.
sine components are going to cause me moment about O. Okay,
Yes, sir.
that is my point. Okay.
So, sir, there the point of action of forces through O. I mean, the O is the center of all
O is the point.
force point.
O is the point about which we are considering all the rotation for this particular case.
Okay, sir.
Okay.
Yes.
There may sometimes we may also have case where you have the exactly opposite happen. I'll not be having the moment above of the sine components, but only the cos component. That is also possible. Okay,
Yes, sir.
both cases are possible. I just have to take care about it. Okay, when I
Okay,
am
sir.
solving the problem, I have to take care about it. So we'll try to take a question about that example also. Okay. So I have Ry which is there, Ry it is equal to R into sine theta. Then Ty which is there, that is P sine theta 1 in Qy which is there, that is Q sine theta 2. Now the moment which is there, if a moment of the force Py which is there, so for moment of the force is Py, and what is the minimum distance that it acts through which it is acting? The minimum, the perpendicular distance which is there, that is my, for the force P which is there, the minimum force it is distance it is d1. For the force R, the minimum distance it is d, and for the force here, the minimum distance which is there, that is d2. So this equation, my equation number 2 which is there, my equation number 2 becomes as R into sine theta equal to P sine theta 1 plus Q sine theta 2. Now for all these length which are there, okay, what if in the LHS and in the RHS I am multiplying them by the distance OA, multiplying by OA in LHS and in RHS. So implies R into OA sine theta equal to P into OA sine theta 1 plus Q into OA sine theta 2. Now, if I am considering the triangle, the small triangle which is there, so I have OA, with OA is my OA is my adjacent side, and theta it is my angle. Sine theta it is my angle. So what happens when I am multiplying OA and sine theta? So according to the definition of sine theta, what is it? Sine theta it is opposite upon hypotenuse, right? So here what happens, this length OA becomes my hypotenuse. So the length OA sine theta which is there implies I can write it as R into D, the adjacent side. For here, for D it will be there. For the R, this is becomes my adjacent side. The same way is R into D equal to P into D1 plus Q into D2. Because for all the three triangles which is there, OA it is my hypotenuse, right? For all the three triangles, OA is my hypotenuse. So hypotenuse multiplied by the sine of angle which is there. So that gives me my opposite side of that angle. So I have R into D equal to P into D1 plus Q into D2, which is nothing but my statement of, which is my expression for Varignon's theorem. So hence, the Varignon's theorem, it is proved. This may come as a 5 marks question, okay, in your university examination. So from the university point of view, for a 5 marks question, you can you can study about this, and this will be you can keep this as one of the questions for your oral examination also, okay. During a practical session for your oral examination also, this will be one of your questions. So please take a note of that, okay. Now, okay, so this we discussed all about this. We discussed about the Varignon's theorem. Now I have to be looking at, okay, how I'm going to solve in the case of solve for a parallel force system. Okay, how I'm supposed to find out the resultant for a parallel force system. So I have a set of steps which are there. Firstly, find out the resultant. So sigma f which is there. So it may be sigma fx, it may be sigma fx, it may be only sigma fx, or it may be only sigma fy, or it may be both. Okay, it may be having both sigma fx and sigma fy components. Okay, so depending on the direction on which the forces are acting, you may be having both components. So if you're having both components, then under the root of sigma fx square plus sigma fy square and tan inverse of sigma fy divided by sigma fx. So as we discussed for the concurrent force system, those equations remain in position, and along with that we will also be considering the effect of moment, sigma m. Okay, I'll also be considering the effect of sigma m. And after finding out sigma m, I'll be applying Varignon's theorem. So sigma m equal to R into D. In this D which is there, then I'll be finding out the position of the resultant, okay, with respect to O. So these are the steps. Okay, please note them down. I'll give you a couple of minutes to note it down. Okay. Shall we proceed? Hello.
1 minute.
Yeah. Okay, so we'll proceed. We'll take a question here. Okay. So now I am supposed to find out the resultant for the following force system. And along after finding out the resultant, okay, so we'll also mark the resultant which is here. Now, and since nothing is mentioned here about from which point I have to mark the resultant, okay. So let me take it as marking the resultant. Okay, we'll find the resultant. Okay, about the point O. Okay, or we'll find out the moment which is there. Okay, so effect of the moment which is there, we'll find that out about the point O. Okay, so firstly let me observe here. Okay, what are the forces that I am having? Firstly I have a for my first observation, do I have any horizontal component of the force here? Do I have any horizontal force?
No, sir.
We do not have any horizontal force, so sigma fx which is that is becoming equal or already equal to 0, right? Because we do not have any horizontal component. Next I have to look only for sigma fy. So here this is minus positive y direction, positive y direction, positive y direction. This is negative y direction, negative y direction. So let me write that out. Firstly, I have sigma fx which is that is equal to 0, sigma fy equal to minus 70 plus 100 plus 50 minus 86 minus 34 plus 90. Okay, so sigma fy, the total it is coming to be as 50, and it is the units are in Newton. Okay, so 50 Newton. Next, I have to find out sigma mo. Okay, so here I am finding out the moments about the point O. Now, what is the moment about the force 70 Newton? Can you tell me? Okay, so we'll do it together. Okay, so what is the moment of the force 70 Newton? Can you tell me?
0.
Why do you think it is 0? Why do you think it is 0?
So no perpendicular distance.
It is having no the 470 Newton that is passing through the point O. So that does not have any perpendicular distance, right? It is not causing me any rotational effect. Correct. You are correct. Okay, so sigma mo equal to 0 into 70. Okay, so that is not necessary to be written, but still okay. So I'm just added it, or we can always do one thing. We'll just remove it. Okay, so 0 into 70 we removed it. Then the first force 100 Newton which is there, 100 Newton, it is acting at a distance of 1.5 meters. So my moment which is there 100 into 1.5. In what is the direction of the moment? Is it clockwise or anti-clockwise?
Anti-clockwise, sir.
So the effect
Positive.
of the moment it is positive. So plus 100 into 1.5. Next moment, my next force 50 Newton. What is the distance of 50 Newton from O?
3.5, sir.
Yes, the 50 Newton, it is acting at a distance of 3.5 meters. And what is the effect? It is positive. It is clockwise or anti-clockwise?
Positive, sir. Anti-clockwise, positive.
Plus 50 into 3.5. Okay, good. Now what about others? Now somebody else, can you answer? Anybody else? Next one. The next force that is there, that is 86 Newton. What is the distance at which it is acting? 86 Newton, it is acting at what distance?
6.5.
3 plus 2, 5, 5 plus 1.5, 6.5 meters. Correct. And what is the effect of the force?
Clockwise direction.
The moment it is clockwise. So
Positive. Negative. Negative.
remember right hand thumb rule. For the case of moment, anti-clockwise is positive, clockwise is negative. I have to remember that. So here which is there, that becomes minus of 86 into 6.5, right? Next force 34 Newton. What is the distance For 34 Newton, what is the distance?
8.
8 meters.
Okay. And what is the effect? Clockwise or anti-clockwise?
Clockwise.
Clockwise.
So minus 34 into 8. Finally, I have 90 Newton. What is the distance for 90 Newton? From O, what is the distance from O?
10 meter.
It is 10, yes. So the total distance which is there, so that is 10 meters. And the effect which is there, that is anti-clockwise.
Anti-clockwise.
Yes. So plus 90 into 10. So what is my sigma MO? And here my unit which is there, that is in Newton meters, right? Can you give me the total quickly?
$394.
Sigma MO, okay, so that is 394 Newton meters. Now which is there, okay. So here I already found out sigma Fx and sigma Fy. Fx was 0, so sigma Fy was 50 Newton, and that will be equal to R, right? Sigma Fy, that will be equal to R. And here, since my resultant also, it is, since there is only, I am having only the Y component, so that will be acting in which direction? My R, which is that is acting in which direction? Since it is positive, so the resultant is going to act upwards, right?
Upward.
Yes, the resultant is going to act upwards only. So 100 plus 50 plus 90. So my net effect, it is 50 Newton, and that will be acting upwards. Now I have found out sigma MO, I have found out R, applying Varignon's theorem. Sigma MO equal to R into D. So implies 394 equal to 50 into D, or implies D equal to how much? Can you tell me?
$7.88.
Yes, D is equal to 7.88 meters. So now let us mark that. Let us mark that. So here, until here it was 6.55, here it is 7.8 meters, right? So to mark my resultant here, what I will be doing, okay, I'll use the highlighter here. So I have 7.88 meters. Okay, so this is going to be my resultant. Yeah, so this is going to be my resultant R, which is there. R equal to how much? And the magnitude was 50 Newton. And what is this distance here? This distance, it is 7.88 meters. D equal to 7.88 meters. And is it necessary that the resultant has to act from here and only? Is it necessary? मैंने ऐसे दिखाया था कि रिजल्टेंट का इफेक्ट चेंज होता है?
No, sir.
No. Right. So I can show it here also, I can show, or I can show it here. Okay, that doesn't matter. That is about the principle of transmissibility of forces, right? उसी सेम लाइन में आप चेंज करोगे तो फोर्स का इफेक्ट चेंज नहीं होगा. Now let me think about one more thing. Okay, so for the same question, what if I am actually considering the resultant which is there, I am finding or trying to find out about the point A. What if I want to find out the resultant about the point A? Then what will happen?
The length should take from A.
The length I should be taking from A. Correct. Then, so ये केस में, O के केस में मुझे क्या हो गया? 70 Newton force which is there, that cost me 0 moment, right?
Yes,
That
sir.
cost me 0 moment. When I'm considering from the point A, then what will happen? The 50 Newton force, that will be costing me 0 moment.
Yes.
उसके अलावा मुझे और क्या चेंज होगा? The first force, 100 Newton force which is there, that is at a distance of 2 meters. And in this case now, what happens to the direction of moment? 100 Newton, it will be causing me a clockwise moment about A, right? ऐसे rotation
Yes,
effect
sir.
ऐसे होगा ना? So the
Yes, sir.
so what happens? 100 Newton will be causing me a
Negatives.
clockwise moment.
Negative.
The 70 Newton about the
Will
point
be
that will
the
be causing me a anti-clockwise
positive.
moment.
Anti-clock.
Yes. तो मुझे क्या होगा? The moment about A, the moment about O, मुझे वो change होगा. Sign convention थोड़ा change होगा. So that is something that I have to remember. I have to take care of. Okay.
Yes.
Now another possibility. Let me, in the same question, let me give another possibility. Now I found out the sigma Fy. I found out the moment. Now suppose I have to show that all this in ये पूरा resultant जो है. Now this was a complete force system. This I want to change it into a force and a coupled system which is there. Okay. Thus in ये same question में the represent as a force coupled system about O. Then what will I do? I already found out my resultant. I already found out the moment about O. Then what will I do? मैंने force निकाल लिया, moment निकाल लिया. क्या करूँगा? Use your imagination. I have to represent this entire system, which is I have to represent as a force coupled system about O. क्या करना है मुझे?
सर वो रिजल्टेंट फोर्स को 7.88 मीटर अपवार्ड तो अपन ने ओ से अपवार्ड की तरफ राइट डायरेक्शन में तो अपन ने प्लॉट कर दिया है, तो उसको एंटी क्लॉकवाइज में ओ के ऊपर में रखेंगे.
No. Leave the case that we already completed. ये अभी मेरा नया क्वेश्चन करके सोचो कि मुझे ये जितना भी मेरा रिजल्टेंट है उसको मुझे फोर्स कपल्ड सिस्टम बोल के दिखाना है. तो मैं क्या करूंगा उसके लिए? मैंने ऑलरेडी 7.88 में जो दिखा है उसको भूल जाओ. So if I have to do like that, okay, let me explain. If I am doing like that, then I'll be marking my resultant, which is there R equal to 50 Newton about the point O, and it is acting upwards क्योंकि R का net effect upwards था. Along with that, now what I'll do? ये sigma mo जो है, sigma mo it is positive. So positive मतलब क्या हो गया? Sigma m का effect कहाँ से है? Anti clockwise है ना?
Yes,
The
sir.
moment anti clockwise is positive. So now firstly I'll be marking the force of 50 Newton from O. Secondly, I'll be adding a moment here. I'll be adding a couple here. And for this couple which is there, I'll be writing it as, वहाँ पे लिखने को जगह नहीं तो मैं यहाँ पे लिख रहा हूँ m equal to 394 न्यूटन मीटर्स. और m नहीं लिखा तो भी चलेगा, 394 न्यूटन मीटर. ये मैंने दिखाया, मतलब इसका मतलब है कि वहाँ पे वो कपल है. 394 न्यूटन मीटर्स दिखाए तो भी काफी है. Okay, so with this part, okay, what I have shown you, that how I can change this entire force system, which I have changed this entire force representation to a force coupled system. Okay, now this force coupled system, if I want to replace with a force, then this 50 Newton which is there, I'll be showing at 7.88 meters. So then that force which is there, this force and coupled system, I am representing it as a force. जो हमने यहाँ पे किया था प्रीवियसली. यहाँ पे क्या किया था हमने? यहाँ पे मुझे फोर्स और ये कपल था, तो ये 50 न्यूटन है, ये 394 न्यूटन मीटर्स है. सो ये डिस्टेंस कैसे निकाला मैंने? 394 डिवाइडेड बाय 50. सो दिस डिस्टेंस व्हिच इज देयर, दैट विल बी d will be 7.88 meters. Okay, now you are able to understand. Now you are able to
सर
understand.
इससे एक पहले वाला स्लाइड दिखा ना, इससे जस्ट पहले वाला जो आपने दिखाया था. हाँ ये वाला. ओके सर.
Okay, so यहाँ पे भी क्या किया हमने? मेरा पूरा रिजल्टेंट है. Okay, so now I have that in my entire force system which was there. उसका पूरा रिजल्टेंट मैंने through A दिखाया, and I am showing it as a couple. So ये couple मेरा था 394 न्यूटन मीटर्स का. And here ये जो couple है इसको मैंने अगर डिस्टेंस में दिखाना है, और फोर्स couple को मुझे फोर्स में कन्वर्ट करना है, तो 394 divided by 50, 7.88. So I am replacing that force coupled system with a force.
यस.
So मुझे नेट इफेक्ट में कहीं पे भी चेंज नहीं आ रहा है. देखो, once I am finding all that out, मेरे नेट इफेक्ट जो है, मेरा पूरा कैलकुलेशन के नेट इफेक्ट में मेरा ना फोर्स कहीं पे कुछ कम हो रहा है, ना मेरा मोमेंट कहीं पे कम हो रहा है. These are and what I have shown you in this one question is the different ways with which by which I can represent according to what is asked in my question. Okay, आर यू क्लियर? आपको ये
Yes,
सभी
sir.
जो थियरी पार्ट था समझ में अभी समझ में आया आपको?
Yes, sir. So वो basically बस conversion है ना उस चीज का, force का force
Yes.
couple में और couple force का
हाँ
force.
हाँ, बेसिकली वो कन्वर्शन ही है. So will you okay, we'll take this question in the next session. Okay, तो आपका next अभी अगला सेशन है ना? I think physics है, कौन सा है?
Physics है sir.
फिजिक्स है ना? ओके,
Sir
तो
वो
जो
उसका question दिखा दो एक बार.
हम करते हैं ना, अगर हम अगले सेशन में करते हैं.
ठीक है sir.
हाँ, गिव मी योर अटेंडेंस. ओके, आपका रोल नंबर और नाम दे दो जल्दी से. All of you, give me your roll number and name very quickly. We have only 1 minute left. And I hope the lecture is not becoming boring.
No, sir.
Okay, so you be in this meeting itself. Okay, I hope the next your physics professor has joined or he will be joining. Okay, so we'll join after there. We'll be joining back after the session. Okay, let me stop the recording.